Hello, today we'll review papers rethinking the value of network pruning research my research related to my research area. We know nowadays deep neural networks to become more popular because it efficient in some problem like image recognitions. Here is an example of a deep neural network AlexNet. We see it have 18 layers and we use 5 convolutions with total more than thousands filters. After we visualize the filters in AlexNet, we see many filters are similar, and we will think about how to reduce or prune the filters in AlexNet because deep neural networks even use much computing resources, 100 megabytes and 100 megabytes to store. But some mobile chip device and or camera chips just have a small computing resources. So this is the first pruning method. It's named unstructured pruning method. This pruning method has 3 steps: training, pruning, and fine-tuning. We will use a big model, a pre-trained model, to prune by using some criteria, and after prune we will fine-tune. It's mean retrain to regain the lost performance. There are some common beliefs about pruning. First, simply remove set of redundant parameters without significantly hurting the accuracy by using a large over parameterized network. Both prune architecture and its associated way to be essential for obtaining the final efficient models. So fine-tune a prune model instead of training it from scratch. Here is one of criteria used to prune is prune by weight. It means a criteria we choose the weight has lower values to prune. And here we use normalizations from linear algebra to rescale the value of weights because some criteria return raw values. So we use normalization to achieve adequate rescaling across layer. And we see in the graph the unstructured prune methods, so we lost many accuracies when compared to other methods. And we take some drawbacks. First, 3-state pipeline often fails on large-scale ImageNet benchmark that we see in the graph. This graph is training on AlexNet and ImageNet. Second, Sparkwave matches not lead to compression and speed up without dedicated hardware libraries. So scientists propose the structure pruning method. We see here 2 types of structure pruning method, predefined and automatic. In predefined pruning method, we will decide how much percent of each layer will be pruned before we train the model. The second way will choose automatically by algorithms. We will calculate how many percent of each layer will be pruned. Structure pruning method will prune at the level of convolution channel or even layers, and we don't need to restore to store the pre-trained model. And we got some surprise observations. Structure pruning method with predefined target network architecture directly training the small target model from random initialization can achieve the greater or equal performance obtained from unstructured method. Second, structure method training the prune model from scratch achieve better performance than fine tuning. Here is the dataset and network and pruning method we use to make comparisons and do our experiments. Use CEPHA 10, CEPHA 100 is small dataset, and ImageNet a big dataset. VGG, ResNet, and DenseNet network. We use predefined methods, automatic structure pruning method, and unconstructed pruning method. And about training budget, we will compare apple to apple. So we will computing floating point operation in flops. There are two new notations. Squared E, it means same epochs to unstructured method, and squared B, same flops. Here is our experiment for each kind of pruning method. Here is result for predefined structure pruning method. And we look at squared B. It has better performance, higher accuracy than fine tuning. And next is for automatic structure pruning method, and we got this similar result. Squared B has better accuracy and performance than fine tune in almost case. Fine tune get better, it's a little better accuracy in small data set, but in large scale data set like ImageNet we got higher accuracy. And here is the result for unstructured pruning method based on -2. And we see fine tune get higher accuracy in some case, but not all case. Training from scratch is always better than fine tune. So we see that inherited ways in prune architecture is not better than random, and the prune architecture bring the efficient benefits. And we have some conclusion. Training predefined target models from scratch, you have high accuracy, model is smaller, using less GPU memory and faster than training large model. No need to implement the prune criterion and procedure. Avoid turning additional hyperparameters involved in the prune procedure. And automatic structure prune for efficient architecture in some cases. And for related to linear algebra is I use normalization, matrix normalization in linear algebra for my research. So thank you.